This video will discuss how to find the area of regular polygons. I've got a picture of a regular polygon here that has 6 sides, so it's a hexagon. And as we recall, hopefully, regular polygons are polygons where all the sides and angles are congruent. So in this particular polygon, I've done a few things, one of which is I've drawn radii from the center of this polygon to all its vertices. And this creates a bunch of triangles. And these triangles are both isosceles and congruent. Now I'm getting n of them, where n is the number of sides. So since this is a hexagon, my n is 6. I do have 6 triangles. They're isosceles because all those radii will be congruent to each other. And again, because it's regular, all the sides of the polygon are congruent. So we can show side congruence here if we need to. We have a new word for many people who are watching this video, and it's the apothem. And the apothem is simply just the altitude of one of the triangles that we created here. The other thing I want to remind you of is what a perimeter is, and a perimeter is just the sum of the lengths of all the sides. It's the distance all the way around this polygon. Because it's regular, all the sides are congruent, so all you need to do is find one side length and then multiply it by n. And all I need is the apothem and perimeter to find the area, because here is the formula. Area of a regular polygon is 1/2 AP, where A is the apothem and P is the perimeter. This example wants us to find the area of a regular nonagon inscribed in a circle with radius 5. And let's just remind ourselves what that area formula is. Area of a regular polygon is 1/2 apothem times perimeter. So I need to find apothem and perimeter. So what I've done in my figure here is I've drawn one of the triangles that you can create. The side lengths of these triangles are 5 because we're told the circle radius is 5. And I am dropping that altitude from point L to its opposite side of that triangle, LKJ, which will give me the altitude of that triangle, which is the apothem of the entire polygon. So let me just expand on the size of that triangle and turn it around so I can see what I'm looking at. And here's kind of a blow up of this figure. I'm going to focus on this triangle right here. So we've dropped an altitude, this guy, right, LM, and I have this little angle here. It's saying it's 20. Now let's discuss why that would be. So my n here is 9. If I were to create the remaining, those little vertices here, oops, these aren't coming out so great, but there they are. They're all going to be congruent because this is a regular polygon here. Because there's 9 sides, how many angles are there? 9 angles. So I can find the measure of each. I know all the way around is 360. Then I'm going to divide by 9. That means that all the angles here are 40 degrees, and that's the same all the way around, including over here. So this whole thing is 40 degrees, but because I've dropped an altitude, when you drop an altitude in isosceles triangles, you will actually get 2 congruent triangles here. So JLM and KLM are congruent to each other, and you can easily prove that. Hypotenuse leg is one way. So that means that these 2 angles here are going to be congruent because of CPCTC. I've also marked these, which I'll need later, to show that these 2 pieces will also be congruent by CPCTC. So if the entire angle JLK is 40 degrees, then half of that will be 20 degrees. So both sides are 20. Because basically what I'm going to do now is I have a right triangle. And right triangles are wonderful things. Maybe I'll change the color a little bit so we can see it better. It's this triangle right here. And I know that this is 20 degrees. So I'm going to call LM's length little a, and I'm going to call MK's length little b. Because I can find those lengths, I need to find 2 things, apothem and the perimeter. So let's focus first on the apothem, which I have as labeled A in this diagram right here. That's the apothem. I have a right triangle. I'm using 20 as my reference angle over here. A would be an adjacent side. B is the opposite side. And 5 is the hypotenuse. So if I'm using trigonometry, that will help me find A. Because I want the adjacent, I know the hypotenuse, I'm going to use cosine because cosine is adjacent over hypotenuse, and if you forgot that, you can always use the SOHCAHTOA little trick to try and remember it. So since I want the adjacent, I have the hypotenuse, and I know my angle, that means the cosine of 20 degrees will be the adjacent A, the thing I don't know, over the hypotenuse 5, which is the thing I do know. So now I can just use some algebra to solve for A by multiplying both sides by 5. So A will be 5 times the cosine of 20. And at this point, this is my apothem, but I'm not putting it in a calculator. I'm not turning it into a number yet. I'm keeping everything exact. The key to getting the most precise answer is to not go to the calculator too soon. You want to keep everything as exact as possible until the very last step. So that's the apothem. I found it. Now I need to find the perimeter. I need to think a little bit about this because the big picture here is I want to find, let's say, a side length, right? Then I know I have n of those, in this case 9 of them. So my perimeter is really the number of sides times the length of a side. And in this case, n is 9 times a side. Now if I'm looking at my blow-up picture over here, this is a side, right? That's my S. So I can find half of it pretty easily. I can find B, but how does B relate to S? Well, let's see, S is, just take 2 of those B's, right? So I can substitute here and say that means the perimeter is 9 times S, and S is 2 times the length of that small b, which is 18b. That's my perimeter. So if I can figure out b, I can find my perimeter. And I can figure out b because I can use trig again. Now in this case, here's my reference angle, my 20. The opposite is the thing I don't know, and the hypotenuse is the thing I do. So that would be sine, opposite over hypotenuse. So the sine of 20 degrees will be the opposite over the hypotenuse. And again, I can solve this for b by multiplying both sides by 5. And that's just my b, but I really want perimeter. So I need 18b. So my perimeter, which is 18 times b, will be 18 times b, which is 5 sine of 20. And I can multiply that 18 times 5, I believe is 90. And that's my perimeter. Okay, well once I have that, I've got my apothem, I've got my perimeter. So area is 1/2 AP, which will be 1/2 A, which is 5 cosine 20, times P, which is 90 sine 20. And I can, if I want, I can kind of combine this, make this a little bit smaller. 1/2 times 5 times 90 would be 225. That's all, just the constant numbers. And then I've got cosine 20 times the sine of 20. So again, that 225 just came from 1/2 times 5 times 90. And this is actually the exact area, units squared. Now this is how you would leave it if they said find the exact area. But most of the time, or at least in this example, I don't want that. I'm just going to get a rounded number. So I'm going to go now to the calculator. Okay, so here I am with my calculator. And there's some cool things you can actually do with the calculator. This is a Desmos calculator, and I'm using the app, but you can do this with the web version as well. I'm actually going to type in my formula. So A equals, and I'm just using a keyboard, 1 divided by 2 to get my half, and then small a times p. So I'm just typing in A equals 1/2 AP. That is my formula. The other thing I want to do is to make sure I'm in degree mode, because that's what I'm using here, and I'm just checking by clicking on the wrench, and I am in degree mode, so that's good. But definitely check that, because I know I'm going to be using trig. Now here's the cool thing. So if you look under this thing where the little blinking cursor is, it says Add Slider. I'm just going to click on All. So I clicked on that button All, and it's giving me sliders. And then what I can do is I can actually type in the values here. So in the previous slide, I went and I combined all these things. I didn't even have to do that. So like my apothem, came out to be, when I did this, it was 5 times the cosine of 20. And then my perimeter came out to be 90 times the sine of 20. So just type that in. And then all you do is you just look up to the original one up here. So my A is 72 point blah, blah, blah. It's just a really cool way. If you're using the Desmos Calculator, it just gets there so much easier. So let's go back now and just fill that in. So this is approximately 72.3 square units. So what I would like you to do is try this one on your own. This is one of the U-tries if you're one of my students and you're following this along for a lesson. This was one of the U-tries on the first page on the bottom there. See if you can do it. So what I would like you to do is to pause the video, and then when you have tried it, restart the video. Okay, go ahead and pause it right now. Hopefully you gave this a try and are not just coming back here if I can do it, because hopefully I can, but I want to know if you can do it. So let's see if we got the same answer here. I've got the little picture here. I need to find out what this angle measure is, because I am going to want to use the trigonometry. Let's see, this is a pentagon, so my n is 5. And so I want to find what one of these central angles are. So I'm going to take 360 and divide it by 5. And 360 divided by 5 is 72 degrees, which means that's that whole big angle here, angle BFA. So I want to find half of it, the angle AFG. I'm going to take 72 over 2, which is 36 degrees. So one of those angles is 36 degrees. So if I make this just a little bit bigger, here's my F, G, and A. That's 8, and there's my right angle. This is 36 degrees. So I need to find the apothem. I'll call that one A, and I also need to find this half side, which I will call B. So let's find the apothem. If this is my angle, this will be the adjacent. This will be the opposite, and there's my hypotenuse. I want the adjacent, I know the hypotenuse, so that's cosine. Cosine of 36 degrees equals A over 8, which means A is 8 times the cosine of 36 degrees, and that's my apothem. And then my perimeter is just the number of sides times the length of a side. My number of sides is 5, and the side, right? If that one's B, that one's B, so the whole side will be 2 B's, which makes it 10 times whatever I get for B. Let's see, B is an opposite, and I know the hypotenuse, so the sine of 36, which is opposite over hypotenuse, will be B over 8, which means B is 8 times the sine of 36 degrees. Then I go to my perimeter, which is 10 times B, which will be 10 times 8 times the sine of 36 degrees, or 80 sine 36 degrees. I can just go right now into my calculator and put in the value I got for A and the value I got for P. So let's go do that. So I'm going to get rid of, let's see, this value. My new A was 8. And let's see, this is 36. And then my P came out to be 80, I think, right? Yeah. So I need to change that. And that's 36. And then like magic, if I look back up to the top one, A is 152.1 169, etc. And if I round that to the nearest tenth, say, that's 152.2. So we can now put that in our solution. The area, which is 1/2 AP, is approximately 152.2 square units. And that's basically all there is to it. Hope this was helpful. Thank you for watching.